Okay, so we're going to look at some examples on our forecasting. This file is up on Sakai that we can pull down. So Woodland Hospital has been tracking the number of pints of type B blood used over the past 8 weeks. The data is provided in the table below, and they want to consider 3 forecasting methods: the 3-week moving average, a 3-week weighted moving average, and exponential smoothing. So I'll keep referring back to the sheet, although I am going to bring it to Excel so we can take a look at it. So I've got our pints in there, and so I have F_MA, there's my moving average, WMA is our weighted moving average, and our exponential smoothing. So we want to do a 3-week moving average. So how do we do that? Remember, our equation is going to be, I am going to take the past 3 months, add them together, divide by 3. So they have asked, if you look at part A, it wants to know calculate the forecast for 10/26, 11/2, and 11/9 using this 3-week moving average. And since we're using Excel, we can fill in the moving averages from 10/5, 10/12, and 10/19 easily enough. I can't go before 10/5, the October the 5th, because if we're doing a 3-week moving average, I need 3 weeks of data. The first time I'm going to have 3 weeks of data is on the 5th of October. So how do we calculate this out? Well, once again, it's pretty easy. I'm going to take the 3 previous weeks and just going to add them together. And so we can add them all up, and then I can take it, I get rid of that plus, and divide it by 3, because that's what we're looking at for weeks. And so we get 386.33. I'm actually going to want to use a whole number, so we'll just bring that down to 386. And then I can just sit there and drag it all the way across and calculate out what my moving average is, my 3-week moving average for every single point in the rest of this curve. So I can predict on the 9th I'll need 397. There's another way we can do this, though, because I added those up individually. We can also say average, because that's all we're doing. Highlight these 3. Close it in, it will divide it by 3 for me. I'll get the exact same thing. And since I allow them to index, everything will be fine. Okay, so that is part A. So if we look at part B, calculate the forecast for weeks 10/26, 11/2, and 11/9 using a 3-week weighted moving average. And they would like to use weights of 0.2, 0.3, and 0.5, using 0.5 for the most recent week. And once again, we'll fill in this entire table because we do have it here. So this one, we can't just do an average. We're actually going to have to type and calculate things out. So let's come over here and go, let's make something for our weighted moving average. And so we'll use 0.5, 0.3, and 0.2. Just so I can calculate that out. Now, notice, let's do a sum here, just to confirm that I can do math. So I sum all those up. Sum total is 1. Why do I care? Because that means, let me just put my, where is the thin line? I'll put a line there so I can do my total, just so I don't screw that up later. So it's 1. That means that I don't have to divide by the sum of all my weights. And so here we go. We're going to go equals. We're going to take, we'll start with the previous month. We're going to, excuse me, I did not want to cough in the microphone. We're going to take the previous month. We want to multiply it by 0.5, but we do want to drag it. So let's lock that cell in. Come up here. I'm just going to hit F. I meant to hit F4. There we go. F4 puts the dollar signs in for me. That will never move, which is what I want. And then I'm going to accidentally delete it. So let's go back and do it one more time so everybody can see. I'm going to take the previous month. I'm going to multiply it by my weight. I hit F4 to lock everything in. And then I want to take the next month back. So 2 months ago. And I multiply it by its weight, which is 0.3. I want to lock that in because I don't want that to change either as I drag it. And then 3 months ago, multiply that by my last weight, and once again, make sure to lock that in so I can drag that. And once again, I'm going to reduce it to no decimal points, and then drag it across. And so now I can get that's my weighted moving average for all 3 months. Okay, so everything is rounded there. So now I look at part C and calculate the forecast for those weeks using the exponential smoothing method. And now they want to use a smoothing constant alpha of 0.25. So we'll just come over here and smoothing constant and 0.25. That way we can change it later if we need to. And once again, I am just going to base everything off of the bottom line here. And I want to add some data in here. I just added it to your sheet so you'll have it. But we need some forecasted data to work our equations off of. And actually, we only really need this last one here because everything is baked into that. So let's calculate this out. So our exponential smoothing, what's it going to be? Well, it's going to be our last value, our last forecast, and then we're going to add to that our alpha. We don't want that to go anywhere, so we'll lock that into place. And so alpha, now notice that I just put the parentheses in there. I know when we write stuff, we automatically know, oh, that means that we are multiplying something. If I left it like that, I would get an error out of Excel because it's expecting a function there. So we have to physically tell it, no, I want you to multiply that. Okay, so that's our alpha, and then we need our actual demand from that month. So that'll come up here, and we'll subtract from that our forecasted demand. And if I close that up and execute it, that will tell us what are 387 pints. And now how do we get the next two? Well, we can just roll it over. And there we go. So that is the way that we put down our 3 different methods. So now the question is, part D, provide a recommended, let's try this again. Provide a recommended forecasting method for Woodland Hospital based on the last 5 weeks of data. They would like to use the most accurate forecasting method based on the smallest mean absolute deviation, or MAD. So let us add a new row. And actually, I'm going to just highlight all this. Actually, let's highlight it this way. And I'm going to insert some rows. And then I want to know based on, so I'll label this over here. And this will be mean absolute deviation. We'll make that look pretty here in a second. 2, 3, 4, those 5 weeks. We will title our columns with those. And now we'll calculate out the average deviation. And actually, so let's just call this deviation. And I'm going to merge and center it here so we've got a whole thing. And actually, this is just me personally, I like to fill that in and then use white for the text. That's not going to show up very well under that color. There we go. And so what I'm going to do is I just want to calculate out all the deviations and then I will average them together. So I am going to look at that. That is my forecasted demand. I'm going to subtract from that what was actually used. And so that's fine. That's a 12. Now I do have a problem, and I'll show you what that problem is here in a second. Look at that. I've got some negative demand. I've got some negative deviations in there. Remember, the equation is for the absolute value. So what we're going to do is we're going to come in here. I'm going to throw in ABS. That is the function for absolute value. And that will give me the absolute value of the number in the parentheses. And so now if I drag that over, okay, that is going to give me all positive numbers. And then if I go and drag this down, okay, then I have my formulas all set. But that looks kind of weird. Let's double check that. Oops. So what happened? As I dragged it down, I indexed both of them. I don't want that to happen because I do want the actual demand to stay there. So what do I need to do? I need to lock in the cell F5. Now, I want, if I completely lock it in, so I use two parentheses. What ends up happening is I drag that over. If I look at one of these equations, F5 didn't move at all. I want the columns to index as I drag it across, so I only want to lock in the row. So that way when I drag it down, it doesn't drag. And so if I drag that across now, you can see that's fine. It went H, I, J, but now as I drag it down, everything will be fine. So there you see, I've locked in that top row. I keep the other ones. I've calculated out the deviation between what was predicted and what was actually used. And so now I want to find the average of all those. And so I could just add those up and divide it by 5. I'm going to come over here, mean average deviation. I am just going to do an average. And I can't spell very well. I'm going to do an average of those 5 there. And then just drag that down to give me my averages on all the other ones. And we'll bring up the decimal points here. So as I take a look at it, which one of these forecasted the best? Well, it's going to be the one, if we're doing it based on the mean average deviation, it's going to be the one that has the lowest mean average deviation. So we can see the exponential smoothing method, on average, was off by 9.68 pints on the forecast, which is better than the weighted average, which was off by 11.64 per month, which is better than the moving average, which was off by an average of 13.73 a month. Oops, wrong thing to spin around there. And so that is how we calculate out moving average, weighted moving average, exponential smoothing using this data, and then using our mean average deviation to figure out which of these is the best for our situation, which in this case is the exponential smoothing.